Our learning objective for today then is I can evaluate expressions that have rational exponents. Well, first of all, we have to make sure we understand what it means by rational. What's a rational number? Don't worry about the word exponent right now. What's a rational number? Whole numbers, only if
Counting numbers.
Counting numbers, only if. Think of the first 5 letters of rational. What are the first 5 letters of rational? Ratio. Yeah, R-A-T-I-O. So ratio. What's a ratio? Something over something else. A comparison of 2 things. We have a numerator, we have a denominator, we're comparing. So the ratio of boys to girls in this class is 4 to 7. There are 4 boys, 7 girls, so we would say 4/7 is the ratio of boys to girls. If I asked you to give me the ratio of girls to boys, what would it be? 7 over 4, it'd be 7 to 4. So when we talk about rational numbers, we are talking about them being able to be written as a comparison of 2 numbers. So when you said a whole number or a counting number is a rational number, it is, when we compare it to what? So give me a whole number.
1, 8,
5, okay? So 5 is a whole number. And how can we make 5 into its rational
5 over
form?
1.
5 over 1. We would compare it to 1, wouldn't we? So now, but no, don't say or 1 over 5, because 5, written as a rational number, can only be written as 5 to 1. It can't be written as 1 over 5. That's a different number. That's its own rational number, a separate rational number. Okay? So basically, when we say that we are going to be able to evaluate expressions that have a rational exponent, it's going to be something being taken to a fraction power. So, anybody think they know how to take something to a fraction power? You might? Okay, Cody, go. Give it a try. Throw us out a problem and tell us what you think. The answer is.
Would 5 to the 3rd power times 6 to the 2nd over n, or over 1, would that work?
No, now you've written a fraction problem, but that's not a expression with a rational exponent, with a fraction exponent. You gave me an expression that is a fraction, is what you just did. So I want you to see if you can tell me what 125 to the 1/3 power is. Anybody think they know what 125 to the 1/3 power would be? Okay.
It would be 1/3 of the number times its.
So 1/3 of the number. In other words, you figure out what 1/3 of 125 is, and then take it times itself, maybe. Julia, what do you think?
Like there's like an invisible 1 and take the last. Like you, if there was a number here, you would like if it was 2 and multiply as 1, you take the last digit of it or something.
You're kind of on the right track. Maybe I think they just, like right now, you think you just spit out something that you think is 125 to the 1/3 power?
50?
50? Anybody want to agree with Cody? He thinks it's 50.
No, it'd be 150.
It'd be 150, but these guys up here think it's 75. So I need to know where these numbers are from. Where'd you get 75 from, ladies? Like dealing with quarters. So if you took 125 and you have to take it to the 1/3 power, you're saying you could take 3/4 out of it. Cody, where did 150 come from?
I got it because usually when you're multiplying by a fraction or a decimal point, your number gets bigger if it's less than 1.
Okay, so if I take 1/3 of 9, you're telling me that gets bigger? What's 1/3 of 9? Anybody know?
Or
What's 1/3 of 9?
3.
3.
But that's dividing it. That's not multiplying it.
Who said it multiply?
Well, 9, so 1/3 of 9, that's what we said here, 1/3 of 9, and you said You're saying they divided by 3 then, and that's how they got their answer? Could we do this though also, Cody, and still get the same answer? Could we multiply, and would we get 3?
Yes.
Yeah.
So
Okay.
you're dividing.
All you have to do is put 9 for 1 times 1.
Yeah, so no, that's when we're trying to find 1/3 of something. That is a multiplication, or it can be also become a division. But this is to the 1/3 power. Now remember when we took something to a negative power, did it get negative? No. It got what?
Larger.
Smaller, didn't it? If it was a number greater than 1, the base was greater than 1, and we took it to a negative power. Do I need to separate you guys? Okay, did it get smaller or larger?
Smaller.
It got smaller, didn't it? Okay. Now, so it's kind of like, you know what, maybe we're thinking, well, because it's to a fraction power, that means, you know, I gotta multiply by that fraction. Well, we didn't multiply by a negative number when we had
You
negative
multiply by
exponents, did
itself.
we? Okay, so I want you to try it on your calculator. What's 125 to the 1/3 power? Hey, where do these, I still have people coming to class without a calculator.
Was 5.
Equals 5? Nobody gets that. Anybody else agree with Cody? Does your calculator say 5? Yeah.
You saying like put like 125 over the other?
I'm saying you're gonna take 125 and raise it to the 1/3 power. Not multiply that 1/3, take it to the 1/3 power. Anybody else get 5, or did you get some other answers? Did you guys get 5? Yeah? Okay. And does anybody know what relationship 5 has to 125?
Yes.
Other than it's 125 to the 1/3 power?
5 to the 3rd power is 125.
Oh, and 5 to the 3rd power gets you back to 125. Or in other words, 5 times 5 times 5 is 125. Do we agree?
I guess. I get it.
If I ask you for the square root of something, what do?
You
If I say,
times each other.
You find what number times itself gives it to you, right? So if I ask you for the square root of 25, you say it is 5. I wonder if we took 25 and instead of using the square root key, we took it to a fractional power. Anybody want to guess what fraction power we think you could take 25 to that would give you a
2.
5?
1/2. 2.
2. Well, go ahead and try 25 to the 2nd power, and that doesn't give you 5. Then try 25 to the 1/2 power and see if that works.
I imagine 1/2.
Which one gives us 5?
1/2.
25 to the 1/2 power. Then anybody want to take a wild guess now then what, 625 to the 1/4 power? Is what your calculators, I said a wild guess. The calculators don't wildly guess, they just guess. So 625 to the 1/4 power,
5 to the 4.
it would be 5 to the 4th. No, 5 to the 4th gets you 625, but what's 625 to the 1/4 power?
5.
5. Okay, check it out on your calculators now and see if it is. See if we're right. Is 625. You know, girls, I'm so disappointed because you're not engaged here. What's going on? So is it 625 to the 1/4 power? Is it 5?
Yes.
Huh. So, you know what? I think we're starting to see that what we're going to be doing today, when we're taking something to a fractional power, we're starting to discover that, you know what, we're really looking for what number, as Julie was trying to say, you know what, it's kind of like that number that's on the bottom, you're trying to figure out, you know, like, she just wasn't really sure how to say it. So let's just start going here and let's figure out what's going to happen. When we have this little n up here in the crook of a radical sign, and then we have a b underneath it, this is read the nth root of b. And if it's b to the 1/n power, they really mean the same thing. So no matter how it is written, if it's written with the radical sign or it is written with a rational exponent, it's asking what number times itself n times is b. What number times itself n number of times is b? It would get you to b. N is what we call the index. I did pass out the notes, right? Okay, N is what we call the index and tells us which root of B to find. Now, these are all terms that you need to start making sure you get a grasp on here. When they ask you for the root of something, they're really asking you for the index of something. They're asking you for what number times itself that many times will get you back to the base. So, like number 1 here, 8 to the 1/3 power. It is asking for that denominator right there is our n. It is asking for the 3rd root. So why don't we put right here that n equals 3 here, okay? N is actually equal to 3 there. So it is asking for the 3rd root of 8. In this one, our b is 8. So b equals 8. So it's asking for the 3rd root of 8. Or in other words, it's asking what number times itself 3 times gets you to 8. And that is 2. Okay, let's try it. 2 times 2 times 2. Would that get us to 8?
Yes.
Yeah. So therefore, we would say 8 to the 1/3 power is or equals 2. Check it out on your calculator to make sure we're right. We're not going to use our calculators again, by the way, in this lesson. But we're just using them to help make sure that we are doing this accurately. So is 8 to the 1/3 power 2? Okay, so go ahead. I want you to see if you can just fill in the blanks here. 81 to the 1/4 power is asking for the what root of what? And then state that a little bit differently, saying, well, saying what number times itself, how many times. So when you see 81 to the 1/4 power, you know I can't use a calculator for this. I want to be smart as the calculator without it. So 81 to the 1/4 power is asking for which root class? The 4th root. Julia is not the only one that's breathing today, by the way. It's asking for the 4th root of what?
81.
And Cody, join in, class. What number times itself?
4 times.
What number times itself 4 times is?
3.
Thank you. Somebody has to override him anyway. And then it's Julia. The Julia Cody team. And the rest of you are on vacation? Even if you're wrong, say something, okay? Okay, so what number times itself 4 times is 81? 81 to the 1/4 power means, and this is how you'll show your work. Just prove to me that you're not using your calculators. What number times itself 4 times is 81?
3 times
Oh.
the power.
3 to the 4th?
3 to
So let's try it. 3 times 3 times 3 times 3.
9.
3 times 3 is?
9.
9. 9 times 3 is?
27.
27. And 27 times 3 is?
81.
Or in other words, on the power chart is 3 to the 4th power, 81.
Yes.
Yeah. So we are not going to stop there. We're going to say, well then, that's my work that shows that 81 to the 1/4 power equals?
3.
3. That's our final answer, isn't it? 81 to the 1/4 power equals 3. What times itself 3 times, 4 times, excuse me, gives you 81. Okay, now, without us even writing it down, I want you to tell me what 81 to the 1/3 power is then. Oh, no, that was a bad question. 27 to the 1/3 power. Cody, thank you for raising your hand.
3.
3? Everybody agree with him? He says 27 to the 1/3 power is 3. Do you agree with him, Noah? Devontae, you agree? Ladies? Yeah, Julia does? 27 to the 1/3 power means what? What?
3 cubed.
Number times its
Self.
self. How many times?
3 times.
3 times gives you
27.
27. And we just, it shows right here. 3 times 3 times 3 is 27. Isn't that what we said? So 27 to the 1/3 power would be 3. Okay, trick question for you, Calvin. Are you ready? No?
No.
Okay, we'll get ready. Okay, it's coming. Okay, 9 to the 1/2 power is you can pass it to whoever you want, but it can't be Cody or Julia. Or come up with the answer. Noah? Okay.
I said Aurora.
Oh, Aurora.
Either works.
Aurora. Well, we'll go with Aurora. She can fly over here today. 9 to the 1/2 power Aurora is. She says 3. Do you want to agree with her, Calvin? No? Okay, well then, Calvin, you better come up with your own answer.
I said quarter or?
9 to the 1/2 power. No. 3.
9 doesn't divide into
2 doesn't go in. I know, darn, 2 doesn't go into 9 nicely, does it? So.
9. Yeah.
But it does go in there right away. 9 to the 1/2 power means what? Noah?
3.
3 times itself.
It means what times itself
2 times.
2 times gives you
9.
9. So Aurora was right. It is 3. 9 to the 1/2 power is 3. Or in other words, 3 times 3 is 9. Okay. I know. I was, just trying to get Calvin to life over there. And I think I did it. Okay, number 3. 121 to the 1/2 power plus 256 to the 1/4 power. Oh, this sounds like the pi worksheet. Okay, so here's another way it could be written, and I just want us to practice that also. We could write 121 to the 1/2 power as the square root of 121. The index, the n, is 2 in this one. So n is 2, and notice, but there's not a 2 here. How come? Well-
Because it's square, that just means square root.
Yeah, when there's nothing written there, it means square root. The radical sign means square root. When there is an index written there, then it's not square root anymore. Now it might be asking for the cube root, or the 4th root, or the 10th root, or who knows what, depending on what is written there as the index. So we don't have to have that 2 there. It's kind of like we don't write 7 as a power. We don't write 7 to the 1st power. We know that there's an invisible 1 there. Here, there's an invisible 2. But here, we have to put that 4 there, or it would mean square root. Here, this says the 4th root of 256. So these are 2 different ways. So this is an or, okay? I want you to put an or there. That means the same thing. If you see it written as 121 to the 1/2 power, it means the same thing as the square root of 121. If you see 256 to the 1/4 power written as the 4th root of 256, they mean the same thing. In either case, we are looking for the square root, or the 2nd root, you could say it that way, of 121, and we're looking for the 4th root of 256, and we're going to add them together. We're going to find their sum. So basically what I want us to do here, first of all, is we have to find what times itself equals 121, and then what times itself 4 times equals 256, so that then we can do our addition problem. Anybody know what times itself is 121? No?
11.
11. Okay, so the square root of 121 is 11. If you didn't know that yet, get it memorized. Now this one you might not have memorized. Anybody think they know what times itself 4 times would get us to 256? Cody?
4.
4. Okay, so 4 times 4 times 4 times 4. Or in other words, I bet on your powers table, you could check Cody out, is 4 to the 4th power 256.
Yes.
Okay. So now what we just found is we found the square root of 121. Let's just circle one of them because that's, and we found the fourth root of 256. So now we can come over here and do 11 plus 4 and get our final answer of 15. Okay. For the fun of it, let's do that on our calculator and see if it works. Is 120, let's do the fractional power way, okay? Is 121 to the 1/2 power. If you have to close any parentheses after that, make sure you do. Plus 256 to the 1/4 power. Does the calculator agree with us that the
Yes.
answer is 15? So again, we're not going to use calculators, but we can use them to help verify that we know what we're doing. Anybody have any questions on so far? Okay, tell me then, what's another way I could write 27 to the 1/3 power with a radical sign? What would go out here? A 3. What would go as our radicand, it's called? The number underneath the radical sign. 27. Okay, and then, what would I put here for this one? A 5 up here is our index, that's our n value. And what's our b value? A 1, our radicand is 1. We're really looking for the what root of 27? Third root, we're really looking for the third root of 27. And we're going to subtract from that the, what root?
So,
Fifth
fifth,
root of
1.
1. So these are the kind of thought processes that should go through your head to help you be able to say, how am I going to get to this answer without having to let the calculator do it for me? So we are looking for what number times itself 3 times gives us 27. And that is 3, you say? Everybody agree? Okay. So the third root of 27 is 3. We're looking for what times itself 5 times gives us 1. Well, it's going to be what?
1.
1. What's the 100th root of 1? 1. Because no matter what, if you keep multiplying by 1 by 1, what are you going to get? 1, no matter what. So we come over here and we say we have 3. The third root of 27 is 3. Take away the fifth root of 1, which is 1, and our final answer
2.
is 2. Okay, who's our work ahead? Check this out on the calculator, make sure we're the right person. Anybody? Not yet? Right. Okay. Anybody get it? You right? Kayla's shaking her head. Yes, we are. Okay. Questions before we go to the back and practice some more? I'm not sure what to bring in the back, so let's just see. Okay. Well, that looks like fun. We're using a property that we just quizzed on first. It's a, what's this called?
Quotient.
A quotient. A quotient to a
Power.
power. When you have a quotient to a power, you give the numerator the power and the denominator the power, which I already did for us, didn't I? And then we say, okay, well, I have another way I could actually write that. 49 to the 1/4, 1/2 power means what? With a radical sign, how could I write it?
Unfortunately.
Okay, second root, do we need that there? No, because remember when it's not there, that means second root or square root, so we really don't need to put it there, but you can if you want. And the 49 is what we're finding the root of, the square root of. And this one is the square root also, so we can just do the square root of 81, right? Well, this is easy. What's the square root of 49?
So
7. What's the square root of 81? 9. Can that be simplified? So what we're really saying here is what we just found, we found the half power, of 49/80/81. In other words, our answer now, if we take it and we take it times itself, that n number of times, which would be 2, if we took 7/9 times 7/9, would we get back to 49/81? Is 7/9 times 7/9, is that 49/81?
Yes.
Yeah. We were really looking for the square root of 49/81, and that happens to be 7/9. Okay, you go ahead and try number 6 then now on your own. All right. You have a quotient again, being raised to a power. So get rid of the parentheses first. In other words, use the property that will get rid of the parentheses. What's the final answer to this one?
1/4.
1/4. And again, how could we verify that we have a good answer without the calculator? Well, what should be true? If this is the correct answer, what should be true?
If you take 1 to the 3rd power.
Levante? What should be true? Noah?
If you take 1 to the 3rd power, you should get 1. And if you take 4 to the 3rd power, you get 64.
Okay. So if you take the numerator to the 3rd power, it should get you back to the numerator that was in the parentheses. If you take the denominator to the 3rd power, it should get you back to the denominator that was in the fraction. Or, what's another way we could look at this? Cody?
take 1/4 times 1/4 times 1/4.
You took 1/4 times itself 3 times, it should get you back to 1/64. And would it? It's 1/4 times 1/4 times 1/4, 1/64. Okay, so again, how does this get written? First of all, applying the quotient property. Tori, what would I do to get rid of the parentheses?
Put 1/3, maybe 1/16, and then 1/4, and 1.
Okay, Faith, I helped her pass it to you.
81 to 1/4/16 to
Okay. Written as in its radical form, Michaela, could you tell me how I would write it then? Like what would be the number outside in the 4, and then what would be underneath the radical sign? 81. And downstairs, Aurora, what would it, or Abby, I haven't picked on you yet.
4.
Yeah, okay. So we're really looking for what times itself 4 times gives us 81, what times itself 4 times gives us 16. Aurora, what times itself 4 times gives me 16?
2.
2. Okay, let's check it out. 2 times 2 is?
4.
Times 2 is? Times 2 is?
16.
Okay, that appears to be the right thing there. Okay. What times itself 4 times gives you 81? Clarion? Try. What times itself 4 times gives you 81? 3? Let's try it. 3 times 3 is, class? 9. 9 times 3 is? 27. 27 times 3 is? Are you sure? Okay. So the fourth root of 81 is 3. And so now we say, okay, well now I can replace the fourth root of 81 with a 3. I can replace the fourth root of 16 with a 2.
You get 1.
And we could either say it's 1 1/2 or we could leave it as 3 halves because notice it was an improper fraction to start with, wasn't it? Before we found its root, fourth root. So we can leave it as an improper fraction here also. Or in other words, if we took 3 halves times 3 halves times 3 halves times 3 halves, what should we get?
81 over 16.
81 over 16. Yeah, that's right. Okay. Yeah, there any more practice? Is that it? You're all packing up like you're leaving me, so I think that must be it. Okay, let's get started on your homework then.